Production ramp-up and recovery, edit. In late January 2020, production was expected to restart in April and take a year and a half to clear the inventory of 400 airplanes, ramping up slowly and building over time. Boeing might have delivered 180 stored jets by year-end and produce an equal number. Boeing did not disclose any possible effect on deliveries caused by the FAA's withdrawal of Boeing's delegated authority to certify the airworthiness of each aircraft. MAX supplier Spirit AeroSystems said it does not expect to return production rate to 52 per month until late 2022. On the 27th of May, Boeing resumed 737 MAX production at a low production rate, with the rate planned to increase towards 31 per month in 2021. On the 19th of August, Boeing announced that it had received new orders for the 737 MAX for the first time in 2020. Per a statement from the company, Poland's Enter SA entered into an agreement to buy up to 4 737s. On the 28th of October, Boeing indicated that it expected to deliver about half of the 450 stockpiled aircraft in 2021, and the majority of the remainder in 2022, noting that some of these aircraft will need to be remarketed and potentially reconfigured. The delivery rate will also condition the production rate for new aircraft, to avoid compounding the problem. In November, Boeing saw more than 1,000 order cancellations since the grounding in March 2019. Some of these already built aircraft have seen their order cancelled, and Boeing is working to find new customers to take delivery. In late January 2022, Boeing's chief financial officer said the 737 program was producing at a rate of 27 aircraft a month and was on track to ramp up the production. On March 4, Boeing reportedly had preliminary plans to ramp up production of the 737 MAX aircraft to about 47 a month by the end of 2023 as the company looked to extend its recovery from successive crises. On the 12th of July, the company said it had met its goal of increasing 737 production to 31 per month when it reported its June order and delivery tally. In September, however, the company noted that it was regularly having to pause production due to component shortages and other supply chain problems. In late January 2023, Boeing announced that a fourth production line for the 737 MAX would open at the Boeing Everett factory in Everett, Washington. The line will replace the discontinued Boeing 787 line at the factory. However, after the January 2024 Alaska Airlines Flight 1282 accident in which a door plug became detached, after not being bolted in place by Boeing, and resulted in an uncontrolled decompression of the aircraft, the FAA announced it would not grant any production expansion of the 737 MAX until it is satisfied that more stringent quality control measures have been enacted. Certification of the MAX 7 and MAX 10, edit. Following the recertification of the MAX 8 and MAX 9, Boeing resumed work to certify the MAX 7 and MAX 10. In March 2022, there were rumors that Boeing would request an exemption from the U.S. Aircraft Safety and Certification Reform Act of 2020, a safety reform law passed in response to the MAX crashes. The act requires airliners to be fitted with an engine indicating and crew alerting system, ACUS, if type certificated after the 31st of December 2022. Adding this feature would make the MAX 7 and MAX 10 different from other MAX variants, necessitating additional training for pilots. In November 2022, Boeing announced expected delays to the certification of the MAX 7 and MAX 10, then expected in early 2023 and early 2024 respectively. In December, two proposals to exempt the MAX 7 and MAX 10 from the new AUKUS requirements were considered for inclusion in a U.S. defense spending bill, one a simple 2-year extension to the deadline, the second an exemption for aircraft whose certification applications were submitted before the law was enacted, combined with some equipment changes, but neither proposal was included in the final spending bill. The U.S. Congress agreed in December 2022 on a bill allowing Boeing to certify the MAX 7 and MAX 10 without AUKUS, but required that the company must install a third angle of attack sensor in all 737 MAX types as previously demanded by European and Canadian regulators. The company also must install a switch to disable the stick shaker, which distracted pilots during the MAX crashes. Boeing would have to retrofit these design changes to all 737 MAXs already delivered in Canada, Europe, and the US within 3 years of MAX 10 certification. Boeing requested an additional exemption for the MAX 7 in December 2023. The exemption was related to a problem with the engine anti-ice system Boeing had announced in August 2023 that affected all MAX variants. Boeing had found that if pilots left the engine anti-ice system running after icing was no longer an issue, the system could heat the carbon composite inlet at the front end of the pod surrounding the engine, known as a nacelle, to break and fall off, potentially damaging the engine or fuselage. Boeing said that it was working on a fix for all MAX variants and requested that it be exempted from correcting the MAX 7 before it was allowed to enter service. Boeing withdrew its exemption request in January 2024 after being asked to do so in meetings with the U.S. Congress held after the Alaska Airlines Flight 1282 accident. As of February 2024, Boeing estimated that the development, testing and validation of the fix to the anti-ice system would take an additional 9 to 18 months. As of February 2024, the MAX 7 and MAX 10 have not been certified, with the FAA declining to put any timetable on approval. The delays have set back the fleet plans of major carriers including Southwest Airlines and United Airlines, the biggest customers for the MAX 7 and MAX 10 respectively. United also gave a rare, public rebuke of Boeing, saying it was disappointed with the company and would no longer include the MAX 10 in its fleet planning, and had a meeting with Airbus to discuss securing more favorable production slots to enable the airline to introduce A321neos more rapidly to cover the delayed MAX 10s. Design, edit. In mid-2011, one design objective was matching fuel burn of the 737 MAX to that of the Airbus A320neo's 15% fuel burn advantage. The initial 737 MAX reduction was 10-12%, it was later enhanced to 14.5%. The fan was widened from 61 inches, 150 centimeters, to 69.4 in, 176 centimeters, by raising the nose gear and placing the engine higher on the wing and further forward. The split-tip winglet added 1.5% fuel burn reduction and a relofted tail cone another 1%. Electronically controlling the bleed air system improved efficiency. The new engine nacelle included chevrons, similar to those of the Boeing 787, which also helped to reduce engine noise. Aerodynamic changes, edit. The 737 MAX uses a split-tip winglet, designed to reduce vortex drag, which improves fuel efficiency by maximizing lift, while staying in the same ICAO aerodrome reference code letter C gates as current Boeing 737s. It resembles a three-way hybrid of a blended winglet, wingtip fence, and raked wingtip. A split-tip wingtip was first proposed for the McDonnell Douglas MD-12, a 1990s twin-deck aircraft concept. A MAX 8 with 162 passengers on a 3,000 nautical mile, 5,600 kilometers, 3,500 mi, flight is projected to have a 1.8% lower fuel burn than a blended winglet-equipped aircraft, like many 737ing aircraft, and 1% lower over 500 mi, 930 kilometers, 580 mi, at Mach 0.79. The new winglet has a total height of 9 feet 6 inches, 2.90 m. Other improvements include a recontoured tail cone, revised auxiliary power unit inlet and exhaust, aft body vortex generator removal, and other small aerodynamic improvements. The engines on the 737 MAX were also repositioned. The top of the new engine slightly higher than the top surface of the wing, resulting in a change to the aerodynamic characteristics of the airframe. Due to the aircraft's close proximity to the ground, the larger and more fuel-efficient engines did not have enough clearance. As a result, the engines were mounted higher on the wings and further forward, changing the aerodynamic characteristics of the aircraft compared to the 737ing. The MCAS software-based flight control law was implemented to account for the undesirable aerodynamic changes. Structural and other changes, edit. The 8-inch, 20 centimeters, taller nose gear strut maintains the same 17-inch, 43 centimeters, ground clearance of previous 737 engine nacelles. New struts and nacelles for the heavier engines at bulk. The main landing gear and supporting structure have been reinforced, and fuselage skins are thicker in some places, thus adding 6,500 pounds, 2,900 kilograms, to the MAX 8's empty aircraft weight. To preserve fuel and payload capacity, its maximum takeoff weight is 7,000 pounds, 3,200 kilograms, heavier. Rockwell Collins was selected to supply 415.1 in, 380 mm, landscape liquid crystal displays, LCD, as used on the 787, to improve pilots' situation awareness and efficiency. Boeing plans no major modifications for the 737 MAX flight deck, as it wants to maintain commonality with the 737 next generation family. Boeing Commercial Airplanes CEO Jim Alborf said in 2011 that adding more fly-by-wire control systems would be very minimal. However, the 737 MAX extended spoilers are fly-by-wire controlled. Most of the systems are carried from the 737ing to allow for a short differences training course to upgrade flight crews. In addition to the speed trim system, STS, the automatic stabilizer control system has been enhanced to include MCAS. Compared to STS, MCAS has greater authority and cannot be disengaged with the aft and forward column cutout switches. The center console stabilizer trim cutout switches have been rewired. Unlike previous versions of the 737, the automatic stabilizer trim control functions cannot be turned off while retaining electric trim switches functionality. MCAS was deemed necessary by Boeing to meet its internal objective of minimizing training requirements for pilots already qualified on the 737ing. MCAS was to automatically mitigate the pitch-up tendency of the new flight geometry due to the engines being located farther forward and higher than on previous 737 models. During a reassessment of the aircraft in February 2020, both FAA and EASA determined that the stability and stall characteristics of the plane would have been acceptable with or without MCAS. As a production standard, The 737 MAX features the Boeing Sky interior with overhead bins and LED lighting based on the Boeing 787's interior. Engines, edit. Main article, CFM International LEAP. In 2011, the CFM LEAP 1B engine was initially 10-12% more efficient than the previous 61-inch, 156 cm, CFM 56-7B of the 737A. The 18-blade, woven carbon fiber fan enables a 9:1 bypass ratio, up from 5.11 with the previous 24-blade titanium fan, for a 40% smaller noise footprint. The CFM 56 bypass ranges from 5.11 to 5.51. The two-spool design has a low-pressure section comprising the fan and 3 booster stages driven by 5 axial turbine stages and a high-pressure section with a 10-stage axial compressor driven by a 2-stage turbine. The 41:1 overall pressure ratio increased from 28:1, and advanced hot section materials enabling higher operating temperatures permit a 15% reduction in thrust-specific fuel consumption, TSFC, along with 20% lower carbon emissions, 50% lower nitrogen oxide emissions, though each engine weighs 849 pounds, 385 kilograms, more at 6,129 pounds, 2,780 kilograms. In August 2011, Boeing had to choose between 66-inch, 168 centimeters, or 68-inch, 173 centimeters, fan diameters, necessitating landing gear changes to maintain a 17-in, 43 centimeters, ground clearance beneath the new engines. Boeing Commercial Airplanes Chief Executive Officer Jim Alborf stated, "With a bigger fan you get more efficiency because of the bypass ratio, but also more weight and more drag, with more airframe changes." In November 2011, Boeing selected the larger fan diameter, necessitating a 6/8-in, 15-20 cm, longer nose landing gear. In May 2012, Boeing further enlarged the fan to 69.4-in, 176 centimeters, paired with a smaller engine core within minor design changes before the mid-2013 final configuration. The nacelle features chevrons for noise reduction like the 787. A new bleed air digital regulator will improve its reliability. The new nacelles, being larger and more forward, possess aerodynamic properties which act to further increase the pitch rate. The larger engine is cantilevered ahead of and slightly above the wing, and the laminar flow engine nacelle lip skin is a GKN Aerospace one-piece, spun-formed aluminum sheet inspired by the 787. Operational history, edit. After 1 year of service, 130 MAXes had been delivered to 28 customers, logging over 41,000 flights in 118,000 hours and flying over 6.5 million passengers. Fleet Dubai observed 15% more efficiency than the ING, more than the 14% promised, and dependability reached 99.4%. Long routes include 24 over 2,500 nautical miles, 4,630 kilometers, 2,877 mi, including a daily Aerolíneas Argentinas service from Buenos Aires to Punta Cana over 3,252 mi, 6,023 kilometers, 3,742 mi. In 2019, Moody's had estimated Boeing's operating margin to be $12-15 million for each 737 MAX 8 at its list price of $121.6 million, $143 million in 2023, although the list price is usually discounted 50-55% in practice. This high margin was made possible by the efficiencies of production volume and the amortization of development costs and capital investment over the decades of the program run. However, costs have since risen significantly and the margin reduced following the two crashes, the FAA grounding, and the severe disruption to production. Boeing estimated it would cost an additional $6.3 billion to produce the remaining 737 MAX program, $4 billion for future abnormal costs as production restarted, plus an estimated $8.3 billion for concessions and compensation to customers. The rising costs also led Moody's to downgrade Boeing's credit rating. Variance, edit. The 737-700, -800 and -900 the most widespread versions of the previous 737 are succeeded by the 737 MAX 7, MAX 8 and MAX 9, respectively, FAA Type Certificate and Marketing Designation, since 2020 737-7, -8, and -9. The 737 MAX 8 entered service in May 2017, the MAX 9 entered service in March 2018, and the MAX 200, a high-density version of the MAX 8, entered service in June 2021. Deliveries for the MAX 7 and the MAX 10 are expected to begin in 2024, after years of delays. In February 2018, Boeing forecast that 60–65% of demand for the airliner would be for the 737 MAX 8 variant, 20–25% for the MAX 9 and MAX 10, and 10% for the MAX 7. 737 MAX 7, edit. At the July 2016 Farnborough Air Show, Boeing announced that the MAX 7, originally based on the 737-700, will accommodate 2 more seat rows than the 737-700 for 138 seats. Compared to the 737-700, the MAX 7 has a pair of over-wing exit doors rather than the single door, a 46-inch longer aft fuselage and a 30-inch longer forward fuselage, structural regauging and strengthening, and systems and interior modifications to accommodate the longer length. The MAX 7 uses the same wing and landing gear as the MAX 8. It is expected to fly 1,000 mi, 1,900 kilometers, 1,200 mi, farther than the -700 with 18% lower fuel costs per seat. Boeing predicts that the MAX 7 will carry 12 more passengers 400 mi, 740 kilometers, 460 mi, farther than a 319neo with 7% lower operating costs per seat. Production on the first 65-foot-long, 20 m, wing spar for the 737-7 began in October 2017. Assembly of the first flight test aircraft began on the 22nd of November 2017, and was rolled out of the factory on the 5th of February 2018. The MAX 7 took off for its first flight on the 16th of March 2018, from the factory in Renton, Washington, and flew for 3 hours over Washington state. It reached 250 knots, 460 kilometers per hour, 290 miles per hour, and 25,000 feet, 7,600 m, performed a low approach, systems checks and an in-flight engine restart, and landed at Boeing's Flight Test Center in Moses Lake, Washington. Entry into service with launch operator Southwest Airlines was originally expected in January 2019, however, it has been repeatedly delayed. Southwest had ordered a total of 234 MAX 7s. WestJet also ordered 22 MAX 7s, but later converted those into MAX 8s amid the delays. In 2022, Southwest announced that it would take early delivery of its MAX 8 orders to make up for the delay of the MAX 7. As of January 2024, Southwest has removed the MAX 7 from future fleet planning. However, the company said that it remained committed to the type, and was willing to wait until 2026 or 2027 for first delivery. 737 MAX 8, edit. The first variant developed in the 737 MAX series, the MAX 8 replaces the 737-800 with a longer fuselage than the MAX 7. In 2016, Boeing planned to improve its range from 3,515 nautical miles, 6,510 kilometers, 4,045 mi, to 3,610 mi, 6,690 kilometers, 4,150 mi, after 2021. On the 23rd of July, 2013, Boeing completed the firm configuration for the 737 MAX 8. The MAX 8 has a lower empty weight and higher maximum takeoff weight than the A320neo. During a test flight conducted for Aviation Week, while cruising at a true airspeed of 449 knots, 517 miles per hour, 832 kilometers per hour, and a weight of 140,500 pounds, 63,700 kilograms, at a lower than optimal altitude, floor 350 versus the preferred floor 390, and with an unusually far forward center of gravity, the test aircraft consumed 4,460 pounds, 2,020 kilograms, of fuel per hour. The Boeing 737 MAX 8 completed its first flight test in La Paz, Bolivia. The 13,300-foot, 4,100 m, altitude at El Alto International Airport tested the MAX's capability to take off and land at high altitudes. Its first commercial flight was operated by Malindo Air on the 22nd of May, 2017, between Kuala Lumpur and Singapore as Flight OD803. In early 2017, a new MAX 8 was valued at $52.85 million, rising to below $54.5 million by mid-2018. 737 MAX 200, edit. In September 2014, Boeing launched a high-density version of the 737 MAX 8. The 737 MAX 200 or 737-8-200, named for seating for up to 200 passengers in a single-class high-density configuration with slimline seats. An extra pair of exit doors is required because of the higher passenger capacity. Boeing states that this version would be 20% more cost-efficient per seat than current 737 models and would be the most efficient narrow-body on the market when delivered, including 5% lower operating costs than the 737 MAX 8. 3 of 8 service trolleys are removed to accommodate more passenger space. An order with Ryanair for 100 aircraft was finalized in December 2014. In mid-November 2018, the first of then 135 ordered by Ryanair rolled out, in a 197-seat configuration. It was first flown from Renton on the 13th of January 2019, and was due to enter service in April 2019. With another 4 MAX 200s expected later in 2019, though certification and deliveries were deferred while the MAX was grounded. In November 2019, Ryanair informed its pilots that, Due to an unspecified design issue with the additional overwing exit doors, it did not expect to receive any MAX 200s until late April or early May 2020. In 2020, at the height of the COVID travel slump, Ryanair renegotiated its order and purchased an additional 75 MAX 200 aircraft at one-third of the list price. The high-density variant was certified by the FAA on the 31st of March 2021. Ryanair took delivery of its first MAX 200 in June 2021. Besides launch customer Ryanair, other customers include International Airlines Group and low-cost airlines Akasa Air of India,